Welcome to this tutorial on multi-cluster management in Kubernetes. In this video, we'll explore two powerful tools, Kubefed and KubeStellar. These tools help manage multiple Kubernetes clusters efficiently, making it easier to deploy and configure applications across different environments. By the end of this video, you'll understand why multi-cluster management is important and how these tools can simplify your Kubernetes operations. Let's start by understanding why organizations use multiple Kubernetes clusters. First, geographic distribution allows you to deploy applications closer to your users across different regions, reducing latency and improving performance. Second, high availability eliminates single points of failure by distributing workloads across multiple clusters, ensuring your applications remain accessible even if one cluster fails. Third, isolation helps separate development, staging, and production environments, preventing issues in one environment from affecting others. Finally, compliance requirements often mandate that data must be stored in specific locations to meet data sovereignty and regulatory standards. These benefits make multi-cluster architectures essential for modern cloud-native applications. However, managing multiple clusters comes with significant challenges. Configuration synchronization becomes complex when you need to keep settings consistent across all your clusters. Centralized monitoring and observability require collecting and analyzing metrics from multiple sources simultaneously. Cross-cluster service discovery and networking add another layer of complexity, as services in one cluster need to communicate with services in other clusters. Additionally, maintaining consistent security policies and access control across all clusters is crucial but difficult to achieve. These challenges highlight why specialized tools like Kubefed and KubeStellar are necessary for effective multi-cluster management. Now let's introduce Kubefed, which stands for Kubernetes Federation version 2. Kubefed acts as a control plane that synchronizes resources across multiple Kubernetes clusters. It uses a push-based federation model, meaning the control plane actively pushes configurations to member clusters. This centralized approach allows you to manage multiple clusters as if they were a single entity, defining resources once and deploying them to multiple clusters automatically. Kubefed simplifies multi-cluster operations by providing a unified interface for cluster management. To work with Kubefed, you need to understand 6 core concepts. First, federated types are Kubernetes resources that can be distributed across clusters, such as deployments or services. Second, the host cluster is where the Kubefed control plane runs and manages the federation. Third, member clusters are the individual clusters that join the federation and receive configurations. Fourth, templates define the base resource definitions that will be distributed to clusters. Fifth, placement specifies which clusters should receive particular resources, giving you control over deployment targets. Finally, overrides allow cluster-specific customizations, letting you modify resources for individual clusters when needed. These concepts work together to provide flexible multi-cluster management. Here's a practical example of a Kubefed configuration. This YAML manifest defines a federated deployment resource. The API version is types.kubefed.io/v1beta1, and the kind is federated deployment. In the metadata section, we specify the name as my -app and the namespace as default. The spec section contains a placement field that lists the target clusters. In this example, we're deploying to cluster -1 and cluster -2. When you apply this manifest to the host cluster, Kubefed automatically creates the deployment in both specified clusters, maintaining synchronization across them. Next, let's explore KubeStellar, a next-generation multi-cluster orchestration platform. KubeStellar is a cloud-native computing foundation sandbox project that offers a more flexible approach to multi-cluster management. Unlike Kubefed's purely push-based model, KubeStellar supports both pull and push models, giving you more deployment options. It excels at advanced placement logic, allowing sophisticated rules for determining where workloads should run. KubeStellar also includes built-in status aggregation, collecting information from member clusters back to the control plane. Its edge computing optimization makes it ideal for scenarios with intermittent connectivity or resource-constrained environments. KubeStellar provides 4 key features that set it apart. First, workload distribution uses intelligent placement based on custom criteria and labels, allowing you to define complex rules for where applications should run. Second, status collection aggregates status information from all member clusters back to the central control plane, giving you visibility into your entire fleet. Third, edge support optimizes performance for edge computing scenarios, handling intermittent connectivity and limited resources effectively. Finally, scalability enables efficient management of thousands of clusters with minimal overhead, making it suitable for large-scale deployments. These features make KubeStellar particularly valuable for organizations with complex multi-cluster requirements. Let's compare Kubefed and KubeStellar to help you choose the right tool. Kubefed uses a push-based model where the control plane pushes configurations to clusters. It relies on custom resource definition-based federation with a template-based approach for defining resources. Kubefed is mature and stable, having been in use for several years. On the other hand, KubeStellar supports both pull and push models, offering more flexibility. It features advanced placement logic for sophisticated deployment strategies and includes status aggregation to collect feedback from clusters. KubeStellar is specifically optimized for edge computing environments. Your choice between them depends on your specific requirements. Kubefed for simplicity and stability, or KubeStellar for advanced features and edge scenarios. Let's summarize what we've learned. First, multi-cluster management addresses critical needs including scalability, high availability, and regulatory compliance, making it essential for enterprise Kubernetes deployments. Second, Kubefed provides stable, template-based federation for resource synchronization across clusters, offering a proven solution for basic multi-cluster needs. Third, KubeStellar offers advanced placement capabilities and edge-optimized orchestration, making it ideal for complex scenarios. Finally, when choosing between these tools, consider your specific requirements. Opt for Kubefed if you need simplicity and stability, or choose KubeStellar if you require advanced features and edge computing support. Both tools significantly simplify multi-cluster Kubernetes management compared to manual approaches. Thank you for watching, and I hope this helps you implement effective multi-cluster strategies in your Kubernetes environments.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.